Hi everyone. So over the holidays, I've really been kind of engrossed thinking about RAG for chat or XRay for chat, and I really wanted to sort of create a video to walk everyone through my thoughts here. Um, so let's start with why is RAG important for a bit of context, right? So today our chat is brilliant, right? You could ask a question about your code, and we send it the actual question itself, and we add some file context so that the LLM can then answer the question for us, right? But what about questions which are not related to the code, right? Or what about overarching questions which may not be related to the file you're on or the file or the code that you selected? And so I've been really thinking about how we could make those kind of things work, right? So today, as we are asking a question, and let's say the question is, what logging framework does this repository use? You are going to be putting some sort of context from the current file in the context window in the prompt to the LLM, right? But what we don't send today are sort of any examples, right? So if I had asked this question, the current file context would never answer what exactly the logging framework is, right? So the current file is not going to give enough information, and nor is like nearest files. Like even if we look at open tabs, it may not be anything to do with logging, and so you may not be able to answer this question, right? And another problem is that we're using a very small portion of the actual context window that we have. We have this huge context window for Claude 2.1, and we can actually utilize that context window a lot more. So the idea behind RAG is to actually add some good examples in there, right? So that we can actually throw out a better answer, right? So for example, if I were able to pick up, oh, this is write log function and this calculate something function that does or calls the write log, right? We can actually utilize those answers and send them to the LLM so the LLM can actually respond in a much better manner, right? And so that's really the idea behind RAG, or retrieval augmented generation. So I've been thinking of some architectural options of how this could possibly work, right? I could be wrong here and would love to hear some feedback. So basically, let's look at like the architecture today, right? So we've got our various extensions, so the VS Code extension, the JetBrains extension, etc. That talks to GitLab.com, which in turn talks to the AI gateway, that then finally talks to the models, right? So this is how I believe it works today. Now, in the future, we may just remove the need to go through GitLab.com for every kind of request. So we may have AI gateway deployed in each region, so that we can actually use an edge load balancer like GCLB to route to the nearest AI gateway so that we can reduce latency. So that's that. So it would work this way, that we would do authentication again GitLab.com. We would then hit AI gateway with that JWT that we obtain, and that would authenticate us that we can then hit those models, right? Now, before I sort of go on with the future state with RAG, I want to talk about how self-managed works, and this is how I believe it works. I thought it works. I could be wrong here, but the extensions, when it's a self-managed instance, talk to GitLab self-managed, which then authenticates for GitLab.com. We get some sort of token back, and that the token is then sent to AI Gateway to actually authenticate, and then that hits the models, right? So I suppose that'll work this way. We can have to think of the solution completely. So now let's talk about RAG. Like, so how could we look at the current repository information for the user? So based on where the user is currently, and then based on that, send relevant examples so that the question can be answered properly, right? So one of the solutions that I was thinking of was using a CI job, just like XRay is today, and uploading the embeddings into AI Gateway. So the CI job could essentially use some sort of code embeddings model to generate the embeddings for code change, and we could decide which branches that CI job needs to run for. And then once those embeddings are built in, it would then upload those embeddings to AI Gateway. And we could also have things like an ignore file, so that if customers don't want to, upload certain files, etc., they could always sort of put that in an ignore file, and we would not upload that, right? But essentially, that's what I'm thinking the CI job would do. It would upload the embeddings, into AI gateway, right? And it could be generating the embeddings, or the AI gateway could be generating the embeddings. It doesn't really matter. And then finally, AI gateway would be putting it into a vector store, which could be like quadrant or PG vector, anything like that. For self-managed, again, the self-managed users would go through our AI gateway, and so they don't need to run their own vector store. And then in the query path, the extension would authenticate against GitLab, would then call AI gateway. AI gateway, based on the query, would then go generate embeddings, search the vector store for information, and then actually call the corresponding models, right? With the examples baked into the prompt now. So this is one option, right? So this would work so that the AI gateway kind of holds those embeddings. And then we have a centralized store or maybe a partition store for these embeddings. So that's option one, right? Option two is another option where we don't actually store the embeddings on our side, right? So instead, what happens is we still have that CI job, which builds the embeddings and then stores the embeddings in whatever form into GCS, right? So this could be like just like a flat file format where we store all the information into GCS. So what would happen in this mode is that the extension would again authenticate into GitLab. Then the second thing it'll do is it'll download the store from GitLab, right? So just like an asset is downloaded, it'll be downloading this the store from GCS, and then once that store is downloaded, we would call an API to generate an embeddings for the question. So the question has to be embedded, right? The chat message has to be embedded, and so first we'll do that, and then we look up the embeddings in the extension itself, right? So we could use either something like Voy. So Voy is an excellent is a WASM-based search engine for vectors. It uses KD trees for indexing. So it indexes based on like a binary tree basically, and a k-dimensional tree. And so what it's doing is it's indexing and lets you get to those things faster rather than doing just like a flat index where you'd have to search every vector. But essentially, based on distances, it's able to locate the right set of embeddings, and then you can use those embeddings to actually query, enhance the prompt with those examples in the extension itself, right? So what's happening here is we are not storing or processing any of those embeddings. All of that is stored in the extension itself, and it's downloaded from the store, which is stored in GitLab itself, right? In S3 or GCS or whatever object storage they use. And so that's another option. So once the extension has the examples, it enhances the prompts. The prompt is sent to AI gateway, and the actual model is called, and so the model then sends us relevant results. Okay. And then there's another option for RAG where we don't generate any embeddings inside AI Gateway anywhere else, right? So the way it would work is we watch the code, and as the code changes, we generate embeddings, right? So the question is, how do you generate embeddings locally? So we can use something like transformers or JS, which uses the Onyx runtime to actually generate embeddings, right? So let me show you transformers JS. So basically, it's just like you have the Hugging Face transformers library in Python. You can similarly have the Hugging Face. You can use some of the Hugging Face models within transformers or JS. So this would totally run on the extension. It would run locally, right? The difference is that it uses the Onyx runtime, which allows you to run models in different languages. And so that's an advantage, is that everything kind of runs locally. There's no question about where are my embeddings being stored and things like that. And so we would use transformers.js to generate the embeddings locally. We then store that in Voy or a custom memory store, right? And then once it's in there, we would then query the store during the when we actually write the chat message. That then calls AI Gateway, and that calls then the model, which is either Vertex or Anthropic, right? Again, the three architectures are: one, we use AI Gateway and a vector store to store the embeddings. Two is the embeddings are stored as a flat file in GCS, then loaded into an in-memory vector store, in the extension itself. And the third option is to generate all embeddings and everything else in the extension, right? So keep it all locally. So yeah, so those are the three options I could think about. I want to sort of show you a demo of what these options could look like. Okay, so I want to take you to this application here where I've been generating embeddings. Sorry, just a second. So I actually generated embeddings just to see how long it takes. So I generated embeddings for the JavaScript folder within GDK, within GitLab, and it took about 7 minutes or 6 minutes sometimes, depending on what. So what I'm doing for generating embeddings is I'm using this model from Hugging Face, and I'm using the metal performance shaders to actually parallelize that locally, right? So on my Mac. It pretty much works. All I need to do is really copy the NumPy array after the embeddings are generated from the CPU. But basically, if you see, what I'm using is this model for code embeddings, which is trained in a number of languages, and you can see kind of some results that they've done with the benchmark on different languages. And it's not a big model either. It's about 39 MB, right? So that again is not too big a model. And so I've been using that Salesforce code T5P model to actually do the embedding. Let me show you what that looks like. So this is generated the embeddings, and I'm storing it in Quadrant locally. So I've built it for a few things. So for example, this current one here is actually for all the JavaScript files within GitLab. And so if I do you can actually see the size of the embedding store generated. So this is for the GitLab K8s agent, but the one I want is this one here. Actually, I could just do and you can see. So for the GitLab stuff, it is just about I don't know why it's showing so little, but it's about 7. Oh yeah, there you go. It's 7.4 MB. And for the K8s agent project, which is a pretty large project, is about 37 MB. So that's the size of the raw JSON, flat JSONs that have been embedded. And then the Quadrant databases are of the same size roughly. So K8s agent here and the base store here and my DB here, roughly the same size. So, the size of the flat files is the size of the Quadrant DB. So I'm using Quadrant locally. So basically that's using SQLite to store the files. So in order to index anything, all you need to do is run create, and that basically just goes ahead and indexes the current directory or whichever path you specify, right? And it'll generate embeddings using that method which I specified, and then it stores the embeddings in Quadrant. So that's generating the embeddings. Now let's look at searching the embeddings, right? And so there's a search method in which you could give a search query to search for embeddings. So let me show you this one for the K8s agent project, which is actually a pretty large project. There's lots of files. And I already generated the embedding store for that. And if I would go ahead and show you what that looks like. So if I ask it what logging framework does it use, so what I'm doing here is I am first getting the embeddings back, and I'm also sending it to Anthropic with the examples to actually receive the result. So let's just give it a few seconds. And there you go. So it shows you the results. So it says, hey, this is using Zap and Zap Core. And it gives me some examples in Markdown of where it's being used, right? So it clearly tells me where in the repository is being used. So let's see what's happening behind the scenes. So if I actually put in the debug flag here, you could actually see what we're sending to the LLM, right? And if you see, it finds a number of examples of logging. Because it's searching with that question, it's searching the embedding store to retrieve all the list of questions, all the list of code snippets which are being used. The way I'm getting the code snippets, I'm using tree setter to actually go through the whole file, all the files in the repository, generate embeddings for every file in the repository, and then store it, right? And so then you can say based on that, it then responds with the result, right? Let's just do another question. So for the same K8s agent project, I can ask it, how do I call GitLab API from the agent? And hopefully it should come up with a result. Again, you can see it comes up with a number of like good examples here. So I think I'm sending out about 25 examples from the various repository, but you can see it does like retrieve pretty decent ones if you look at the top somewhere. And so hopefully it should answer the question quickly. And so there you see it says, oh, use the GitLab client interface to do this. Here's an example of where it's used. And it also tells you, you can see the project info client and stuff like that. So it gives you some examples here. And it answers the question. So this is an example of using search with retrieval augmented generation. So just to recap here, so just going back to the diagram. What we're doing is basically GitLab is running a CI job that does the embedding store generation and writes the vectors to quadrant. So when I said create on XRay, it was creating the embeddings and storing them in quadrant. And then during retrieval time, the extension will send some code context in the question. We'll regenerate embeddings and search the quadrant store, and then actually send the prompt with the examples to the model. Okay, so that's option 1. Let's look at option 2 as well. So in option 2, so what I've done is I've actually written a way to serve the models here and also serve embeddings. So we do need to be able to generate embeddings for the question. So that has to hit like a server. And so I've just used Fast API to create a quick server that actually just generates embeddings, right? So just an embeddings URL using the same model which I had previously, the Salesforce code T5P model. So let me just show you what this looks in action. So I've got this running using Voy. So like I mentioned, Voy is a KD search tree that is Wasm deployed. So it's WebAssembly based. So it runs in the browser as well. So it's a vector store that it runs in memory and runs in the browser and runs on any kind of platform that supports Wasm. And so here's the same question, which is what logging library is used. And essentially you see that it's loading the full set of examples that I had for the K8s GitLab repository, which is pretty large, right? It's 37 MB, I think. And then I'm actually being able to query the vector store, and it only took 1 second to fully load, index, and query, right? So it's pretty quick. And this is all happening in browser using a vector store in memory, a Wasm-based vector store. So that's the 2 POCs that I've done. I haven't had a chance to look at the Onyx runtime. I'll have to convert the model to Onyx format to be able to do option 3. I haven't really gotten through that so far. But these are my thoughts. So, I think there are various ways to do it. I would love to hear your thoughts on which way seems the best to you guys. And really appreciate you listening in. Thank you.